Welcome back to our third and final segment. We're still exploring, at a microscopic level as to what exactly happens when phase change of a material takes place. For now, we'll shift our attention and look into, a practical investigation to, try and keep track of data in terms of temperature, and time. This would involve the heating of water. As an example. Okay, so apparatus, these are actually the equipment that we use, in the lab at our schools to try and understand, okay, if we want to maybe verify a non-scientific fact, we would conduct an experiment. So this would obviously deal with also some aspects of how do we present the data that we've extracted from an experiment. So the piece of apparatus that we need to be familiar with, it's a beaker, okay, which is in most cases is a glass container. We'll also use ice. So ice in this case will be in solid form. Okay, take note of that because we'll be heating and we want to try and understand as to what exactly happens when a substance changes from solid to liquid and then to gas. And then a thermometer then is an instrument, all right, that we use to actually measure temperature. Okay, and then we'll also have a tripod stand on which we'll place the beaker for us to be able to heat water, and then the gauze becomes the platform on which the beaker is placed, and then the burner becomes our source of heat energy, right? Okay, now suppose these are the results that we obtained. So below here in this case we've got a graph of temperature of water over time while we heat this substance. Okay, now you'd realize that within the first 3 minutes there is no temperature change, okay, as we heat that substance. Okay, and during the first 3 minutes while we're heating it, the temperature is remaining constant, and this is coupled by a change of phase from solid to liquid. So when we talk about the interval of 3 minutes, we're talking about actually this, which is actually 3 minutes there. Okay, because our time axis is on the horizontal axis, and then it means this time is actually our independent variable. Okay, something also that's important in as far as the investigation is concerned. So we can decide to say, okay, we'll take the temperature reading within every 3 minutes or every minute in time interval. So that's for us to decide. We can change that, we can manipulate that. Hence we're saying time becomes our independent variable. And then as a result of recording time within fixed time intervals, then we would also try to check how the temperature changes. Remember, we want to keep track of how temperature changes when a substance is heated from solid until it is a gas, right? Okay, and then between the 3rd minute and the 8th minute. Now, so one may ask, how long did it take for the substance to change from liquid to gas? So this was the phase change that was involved when the substance actually was boiling. So this is actually the boiling point. Okay. So this is boiling as in the process. So the time that it took between the 8th and the, more or less the 11th minute, the substance was undergoing a phase change. And then this happened at a temperature of 100 degrees Celsius. So what that simply means, boiling is the process which took place at that temperature. So we need to be mindful of that. Okay. And then the questions that we are asking ourselves, what exactly happens during phase change of a substance? Remember, phase change is involved, of a substance changing from either solid to liquid or liquid to gas or vice versa. Okay, but because this is heating, so we are saying that from solid, we went to liquid, okay, because we were heating, and then we obtained a gas. So those are the 3 phases of matter, and we want to try and understand what happens in each of those phase changing. Okay, the following aspects actually remain constant or do not change. The size of the particles stays the same. Okay. Also, the shape of the particles that make up that substance stay the same. The total mass of the substance also does not change. So if, for argument's sake, we go to our simulation and look at, let's say, for argument's sake, start with a solid. And then if we hit the solid, what happens? You know, the extent of movement of the particles gets greater and greater, okay? Now you also see that the spacing between the particles as we hit this substance becomes more and more, okay? Now, this is what is exactly involved in as far as phase change occurs. But you also want to take note of what exactly happens in terms of temperature, okay? Just take note of that. As we heat the substance, the temperature is increasing, which is exactly the trend that we obtained from the results that we showed on the graph, okay? Right, so if we can quickly go back to that. So we are saying the particle sizes stays the same, the shape of particles does not change, and also the mass. So the amount of matter remains the same. Why? Because this is actually a physical change, okay? This is actually a physical change. So within a physical change, none of these you know, quantities changes. That is size, shape, as well as mass, right? Okay. Now the speed of particles remains the same, okay? The speed, remember, is how fast these particles are moving. So when a phase change occurs, either from a solid to a liquid, the speed of the particles remains the same, okay? And now the speed actually is an indication of the temperature of a substance. So if the speed remains the same, it means also temperature will not change during a phase change. So when a substance is heated, a solid, so when we heated the ice, okay, and then it changed into a liquid, okay, you'd realize that the temperature remained constant. So if I can quickly go back to the table of results, actually the graph, you see within the first 3 minutes, okay, within the first 3 minutes, what is actually happening? Temperature remains the same. That was the melting that was taking place. So the process of melting took place, okay? And you see that this occurred at a temperature of 0 degrees. So the temperature of 0 degrees of this substance of water, which is water, did not change in the first 3 minutes, right? Okay, and we are also saying the forces between the particles become weaker, okay? Now, as we heat the substance, these particles, they actually gain more energy, okay? While they gain more energy, it becomes easier for them to overcome the forces that keep these particles together. This is accompanied by a change of phase, either from solid to liquid or liquid to gas, okay? Right, and then the spaces, we saw that the spaces which affected the shape of the particles, as we heated, the spaces got bigger and bigger, right? Okay, now we have a different scenario now, for argument's sake, to say, okay, we have a graph below that represents the heating curve of a substance X, okay? It could be any substance, but you'd realize that the trend is actually the same. So at a temperature of -15 degrees Celsius, that substance is actually a solid. So when we heated it for the first 4 minutes, what is happening? The particles gained more energy, and then the phase change occurred at interval 2. So at interval 1, the substance is still a solid, okay? But at 5 degrees Celsius, there was a phase change. Why? Because at that, between the 4th and the 8th minute, what actually happened? The temperature remained constant, okay? Then this substance was heated, particles gained more energy, which explains the temperature increase within stage 3 of that curve. And then at stage 4, another process took place and there was a phase change. And then here, it was actually the boiling, okay? Now, after phase 4, these particles are actually in gaseous form. So the further heating will sharply increase the temperature of these particles because they're now moving faster and faster. Now, in other words, I think we get to a point where we really appreciate that there is a direct link between temperature of the substance and how fast the particles of that substance move. Okay, when we heat, particles gain energy, they move faster and faster. meaning that at a higher temperature, actually we'll have these particles having a high speed or moving very, very fast. Okay, right. And then from this graph, we would ask ourselves simple questions. In which part of the graph does the substance have a definite shape? So this takes us back to the properties of materials, okay, or of a solid. So definite shape has to do with characteristics of the state of matter. So we ask ourselves when, at which point on that graph actually is the substance in solid form. So if we can go back, we understand that between 0 and 4 minutes, we actually have the substance in solid form. So that is actually stage 1 of that graph. So on stage 1, we understand that this substance is actually a solid because we have to relate this property to a particular state of matter, which is actually the solid. Okay? And then B says, what is the melting point? So melting point, we go back to the terminology. We ask ourselves, at a melting point, what exactly happens to a substance? The substance changes its state or its phase, okay? So the process involved at the melting point is, a substance changing from a solid to a liquid, and that happens at a constant temperature. So if we go back to the graph, you'd understand that between the 4th and the 8th minute, that's when there was a phase change, and this happened at a temperature of 5 degrees Celsius. So 5 degrees Celsius is actually the melting point. But the question says that what is the melting point? So we simply go and take it off or read it off from the graph. The temperature at which that phase change took place is actually 5 degrees Celsius. Okay. C says, which part of the curve are the particles of substance X furthest apart? This again takes us back to the properties of the 3 states of matter. We know that when particles are furthest apart, they are loosely pegged, meaning the forces that exist between the particles are actually weak. So this will be a gaseous state. So in this case, we're asking ourselves, when was substance X a gas? So if we go back to our graph, we would understand that at stage 5, it's already a gas, and now we are hitting gas particles. They're moving even faster. But do not confuse that to stage 4, because stage 4 involved the transition or the change from liquid to gas. So at stage 5, we appreciate that this substance was actually a gas. Okay? So D, which part of the curve are the particles of the substance moving at high speed? Okay, high speed suggests that the forces are actually weaker, okay? The spaces are bigger, meaning that the substance is still a gas. So we're still asking the same thing about the properties of a gas, okay? Right. Now, and then if we are to quickly interpret the graph, in short, we are saying at stage 1, the substance X is a solid, and when you heat it, they gain energy. That's why they move faster and faster, which accounts for a temperature increase, okay? Stage 2 involves which physical process? The melting. Now, the solid substance begins to melt, so the speed of the particles remains the same, so does the temperature during phase change. Now, at stage 3, we've got a liquid which absorbs more energy, and the temperature increases sharply. Stage 4, there is a phase change, that's why the temperature remains the same, okay? Right, and then stage 5, the substance is already in a gaseous state. Now, you continue heating these gas particles, so these vapor particles, they continue again to absorb even more energy, and the temperature rises. That's why there was a sharp increase of temperature within a short space of time under stage 5. So if you heat a gas more and more, it gains even greater amount of energy, right? So this is the big idea in as far as, the energy and, how a particular substance actually changes phase. So in terms of the, phase change, we understand that heating increases the temperature. Obviously, the cooling will also have an opposite effect. So in this scenario, we only looked at the heating part, but there is the other side to it again, which has to do with the cooling. Even the trend may not necessarily be the same, but it's just that it will be a downward trend in terms of, because you, instead of heating, you actually cooling. So for today, that's all that we had to do in terms of exploring phase change and understanding how energy plays a role in as far as the physical change between the three states of matter actually takes place. With that said, from myself, Themba Ncube, it's cheers and bye-bye for now.